Welcome everybody to our webinar on RockSim. We are so glad that you are able to join us for tonight's presentation. I'm really excited that with our host for the afternoon, Trent Cybela, was one of the first individuals that I met when I came to the Space Grant family, and that was in August of 2014. He is an alumni of Wisconsin Space Grant. He received multiple scholarships. He was on our Elijah Balloon program. He was part of the Collegiate Rocket Launch program, I believe an undergraduate scholar. Did I get it all right, Trent?
Yeah, I took a lot of money from you guys, Christine. That's definitely sure. That's definitely true.
He also did an industry internship with Sierra Nevada Corporation, which he went on to receive full-time employment, which we like that story. And so he is a mechanical engineer, and again, working with Sierra Nevada Corporation, which he will be spun off to Sierra Space very soon. And so, you know, he's a great guy to talk about Dream Chaser and some of those other things that Sierra Nevada Corporation is works with. So with that being said, I don't want to take up a lot of time because he has a full slide deck and lots to tell you about RockSim, and hopefully when you walk away from today's workshop, you are going to feel as if you know a little bit more. So we are recording it, if I didn't say that, and it will be available for the rest of your team after tonight's presentation. Trent.
Christine.
You are good to go, sir.
Okay, cool, very nice. Thank you for the lovely introduction, and hello, everyone. Like Christine said, my name is Trent, and I've done a few things with rockets in the past through WSGC, and my day job is helping to design them here in Wisconsin, Madison area for Sierra Nevada Corporation and Sierra Space. So I've used RockSim in the past for when I was participating in the rocketry programs through WSGC, and I by no means consider myself an expert, but I think that I have enough information to help you guys get out the door. And so I'll go ahead and share my screen right now, and we'll go ahead and get started. Let's see, let's go screen 2. Let's see. Christine, which screen are you looking at right now? Is it
so right now? I'm seeing your view when you have all the slides on the left-hand side versus presentation view.
Okay, gotcha. So you can see the slide deck right now?
Yes.
Okay, sweet. That's good to know. And as we go through this, everyone, I will be watching chat, and so if you have any questions along the way, please feel free to type that in. I want this to be informal, and I'll answer questions as we go along. And also you can unmute yourself as well and then just say, hey, Trent, and we can talk about it as we go along too. So what we're going to be doing today over the course of the next hour is we're going to start at the very beginning, and we're going to talk about what RockSim is as a program. And my understanding is that some of you may have it downloaded already, others of you may not have it downloaded. So we're going to talk about how you would download it if you do not already have access to that. And if you do not currently have it available with you to follow along today, that's going to be totally fine, because this will be recorded and you will have access to this slide deck too, to go back and review notes. And we appreciate that. Which one updated on slide? I'll fix those dates. Thank you.
And if folks have questions along the way, feel free to put them in the chat and we'll get to them as we can, so that Trent can keep going along.
All right. From there, we're going to go and take a general tour of the RockSim user interface, and then we're going to jump pretty quickly into how to get a model into RockSim, and then how to run a simulation. Which if you, it's pretty easy to get to that point. And then after we've successfully ran a simulation, then we'll take it back a few steps and talk a little bit more about, okay, well, what are some other things that we can do in RockSim? How do we change our rocket model? How do we go ahead and change the flight parameters, the environmental conditions, and so forth. After that, if time permits, we will continue our talk on how to analyze the simulation results, see things like how fast your rocket was moving, how high it went, any anomalies that may have occurred during the launch simulation, and then finally doing modifications to that rocket and potentially showing you how you can build a rocket even from scratch if you wanted to inside of RockSim, as opposed to starting from a pre-built model, which we will import into RockSim. Simulations are very important in engineering because the other route to go if you're not doing a simulation is to do a physical test. And physical tests are very, very useful, but they also take a lot of time and they're very expensive. If we had to run physical tests for everything that I do at my work, then everything would cost probably 100 times more and take 10 times as long to do. And that's the same for what you are all doing here with your rockets. If you had to go and build a rocket and fly it every time to test whether or not it's going to hit a certain altitude or whether or not it's going to be stable, for one, that could be potentially unsafe. But then two, you're talking about a lot of motors, a lot of rockets, and that becomes quite difficult and costs a lot of money. So tools like RockSim are extremely useful for going ahead and launching the rocket in simulation 10, 15, 20 times, and every time just tweaking something a little bit to kind of hone in on the flight parameters that you're looking for out of the rocket. It makes it extremely easy to change things like the material, the diameter of the airframe. It gives you access to a wide selection of different motors that you can plug into the rocket and then just test at your leisure. So generally speaking, simulations are an extremely useful tool, and we are going to leverage them as best we can. So acquiring and installing RockSim. RockSim is one of two programs which help you simulate rocket flights, both at a amateur level, so like high-powered rocketry, like the rocket that I have currently sitting behind me right there, like a 5-footer rocket. But it can also be used for very, very small model rockets too, the type of thing that you would pick up at a hobby shop. One of those two programs is called RockSim, and that's the one that we are going to be looking at today. It's definitely the more refined of the two, and it's brought to us by Apogee Components, which is this company right here. Apogee also sells a bunch of actual rocket parts too, and they're very useful. I've bought a ton of things from them in the past. The other program, which we won't touch on here, is called Open Rocket, which is a freeware version of RockSim, which also is very useful. But fortunately, through WSGC and the resources that they have, we're able to get you all a copy of the paid version of the simulation tool, which is RockSim. So if you have access to this spreadsheet or this slide deck, which you may or may not, we have the link baked in here that effectively will take you to the RockSim page. So if I click that and then drag that over here, you'll see that you do not need to pay initially to get RockSim. You can download it as a free trial. You just need to put in some information, and it will work for a certain amount of days, maybe like 5, 6, 7 days. That's very useful. But moving on from there, you're going to need the appropriate links and codes to unlock the full version of the software and make sure that it continues to work even after that trial period is done. To get the discounted rate, there is a separate link, it looks like, on this page here, slide 5. And if we click that, maybe. There it is. It'll take you to a page that looks very similar, but what you're looking for is this TARC temporary license. It says expires August 31st. I'm assuming that that is not the case, and you'll still be able to gain access to this. And when you click on that, it gives you a lot of information here. Your team supervisor or your team mentor will have more information about the appropriate codes that you need to put in when you are picking up this this version of the software. And that information should be made available to you in the near future if that has not already been brought to your attention. But you would effectively drop that information in this slot right here, and that's going to get you access to the version of RockSim that we'll be using.
So just for clarification, Trent, the license is effective from the day that you purchase it through August 31st of the following year. So these licenses will be good through August 31st, 2022.
Okay, yeah, that's great. Thank you, Christine. More information on downloading RockSim. If you're having any difficulty with this, as you work through that, please get in touch with your supervisor, get in touch with the WSTC staff. But it's a pretty straightforward download. And once you have that downloaded, then you'll be able to use it and play around with it at your leisure. For today's demonstration, we are going to be using this Lock Precision Caliber ISP demo kit. So again, there's another link here in the slide deck that'll bring you to a page where this model exists and can be purchased. But what's great about this is that there is a database of pre-existing model rockets that we can go ahead and import into RockSim, and this is a fantastic model. I've built this once or twice myself, and this is what we're going to be using as our reference for going ahead and interacting with RockSim over the next couple of minutes here. Okay, recap. We just talked quickly about downloading RockSim and what the model kit is that we're going to be using in RockSim today. Okay, so the general user interface, and I'm going to start here, but then I'm going to transition to the actual program and then work in the program with you all so that you can see me manipulating things in real time. But this is the first thing that you'll see when you open up RockSim, and it's broken out into these different sections. At the top here, you have quick action icons, which is like save, print, load engine. But the real important things come below that, which are these functional tabs here and this work area. This is where you're going to be doing the majority of your work inside of RockSim. This is where it's going to show you all the different components that are in your rocket, and will be where you can go ahead and edit those individual components as necessary. I'll go ahead and I'll switch over to the actual application now. Double click this. Cool. And just like it showed in the slide deck, we have a blank interface with our feature tabs up here, and then our component workspace. And currently, there's nothing showing up down here, but in the lower half of the screen, this is where your model rocket is actually going to show up once we have a rocket in the application. So the next question here is, okay, well, where is this file Trent? Where is this model rocket that we're going to import in? So I'm going to drag over my web browser here, and I've already brought this up, but what you're looking for is a website called rocketreviews.com. And on rocketreviews.com, there is this massive list of rocket kits that exist. And it just so happens that our sample rocket, the Caliber ISP, already exists in this list, and we can download it and then import it directly into RockSim. So if I'm on this RockSim library, I can go ahead and I can filter between the many different companies that go ahead and produce rocket kits. And if I go to Lock Precision, which I was already on, and I search for Caliber, you can see it's highlighted right here, the Caliber ISP. And if I click this, it brings me to another page here with more information about the rocket. And if I click download, and save. I now have a copy of that rocket saved to my local computer. So what I can do then, with that saved to my local computer, and it'll probably download to your downloads folder or maybe to your desktop, I can go to this icon up here in the top corner for File Open. And you can see here, this is what I just downloaded, this Lock Caliber ISP rocket. So if I click this and I click Open, here we have a two-dimensional view of that rocket. And so this lower section here has populated with the entirety of the rocket model. And then this upper area here, this component section, has all of the individual components that go into that rocket. As a side note, I look at things that look very similar to this every day in my day job as well. In my lexicon, we would refer to this components area up here as a feature tree. And the reason that it's called a feature tree is because there is a branching relationship between components. So for example, if I'm looking at this component here, which is the payload section airframe tube, and this component in this feature tree has components that are branched underneath it. So if I'm looking at this airframe tube, which is actually this component down here, if you can see my mouse, the section coupler component and the bulkhead component are housed within that section of the rocket. And that's why we call it a feature tree, because we have features in there and it trees out, it branches, and there's a relationship between the components, a logical relationship. And so this is the type of thing that you would see in many different engineering design and computer modeling softwares, which I just think is a fun little factoid. So we have this rocket and it's already built. So we are already very close to being able to simulate the flight of this thing. But the one thing that it is currently missing right now, which comes to my attention, is that it is missing a motor. You know it's missing a motor because if we look down here at the back section of the rocket, a motor would show up as a big gray block that would sit inside of this motor tube down here. And there currently is no big gray block inside of that motor tube. And so this thing is not going to fly unless we put a motor inside of it. So now that we have the rocket model in RockSim, the next thing to do is load that. And so to do that, what I'm going to do is I'm going to go up here to the top corner. And of these quick action buttons at the top, there's one that says prepare for launch. A side note here is that with RockSim and with many other programs that are this feature rich, there's always more than one way to do something. So what I'm showing you right now is one way to add a motor to the rocket model, but there are other ways as well. Another way would be, for example, to go into the feature tree here and then find the motor mount tube and then manually add a motor to it from this particular screen, but we won't do that right now. We won't do that. We'll get to modifying these components at a little later time in the presentation. So again, I'm going to go up here to this prepare for launch button. I'm going to click that. And up at the top here, we see a whole bunch of tabs again. And the first tab is the engine selection tab. So currently there is no engine or motor. You have to apologize. Engine and motor get used interchanged quite a bit in high-powered rocketry. So if I say motor and it says engine, I apologize. I'm referring to the same thing. So what we want to do is we want to go ahead and choose an engine. And so I'm going to click this button right here. And here's one of the great things about RockSim, which is that it already has big databases of commercially available, ready to buy off the shelf rocket parts and rocket motors. It's not a full list, and we can talk about how to get other motors and other parts into RockSim that currently don't exist here. But for the purposes of this demonstration, there are plenty of motors that exist, plenty of engines, excuse me, that exist in this database. And so what I'm looking for, because I know that this model the rocket has a 54 millimeter motor tube. And so what I'm going to do is I'm going to filter by the diameter in millimeters of these various rocket motors. And I'm going to be looking for something with a 54 millimeter diameter, which looks like all of these right here. And I'm not exactly partial to any one of these particular motors. All of them will do for the purpose of this particular exercise. So I'll just go ahead and I'll select this this I-65 motor right here, and I'm going to click that here, and then I'm going to click OK. All right. So we see immediately that something's changed. You can see in our simulation properties window, we have this big, oh, okay, I lied, it's not gray, it looks like it's brown. This large brown circle that demonstrates that there is a motor or engine in the back of this rocket. And then also, if I take this away, you can see that our main diagram right here as well also has a motor shown shaded in there too. So we know we did a good thing. And doubly, we know that we did a good thing because you can see if you look closely that that motor fits inside of this motor tube. You know, if we were to load in a motor that was too small or too large, then it would overlap that tube and would not be the end of the world, but definitely would demonstrate that there's something wrong with our design because in the real world, in the real physical world, those parts wouldn't go together properly. So we're almost there now. And there are a bunch of different things that you can change in all of these various tabs to alter the performance and of the rocket. But right now, what we're focused on is just making sure that we can launch the rocket and that it comes down safely on a parachute. So to that end, I'm going to go over to the Flight Events tab. And in the Flight Events tab, there's not much going on here because we have a very simple rocket, but I have an event description that says deploy at apogee. And so what that is saying is that our parachute, which you can see down here in this lower section of the screen, is this little square or rectangle with a P in it. What that says is that when this rocket reaches apogee, or the top portion of its flight, where it starts bending over and coming back down to the ground, it's going to deploy that parachute. And in this particular case, that's exactly what we want. In future simulations, maybe we won't want that parachute to come out immediately at apogee. Maybe we'll want it to come out a couple seconds after, or even specify a specific altitude where we want that parachute to come out, because one of the problems with deploying a parachute at apogee is that if the rocket is flying really high and that parachute comes out while the rocket is very high, that rocket's going to travel a very, very far distance away from you before it actually lands on the ground. And we typically try to not let our rockets drift miles and miles and miles, one, because it becomes difficult to find them, and two, because I don't like walking. So we have deployed apogee set. So I will click OK, rather I won't click OK to that. I'll move on to the rest of the simulation controls really quickly. Nothing in particular I want to change on this tab. This is high level stuff. The starting state tab, this one's interesting. This one allows you to change the length of the launch rail that your rocket is launching from. For our purposes, 72 inches is more than adequate. And also the launch angle too. Launch angle and this little dial that I can twist around left and right is a very useful tool. Because one of the things that's going to be very useful in your simulations is dealing with the effects of wind on your rocket. Because if you're trying to hit a particular altitude or are trying to get your rocket to achieve a certain behavior in flight, the wind is really, really going to mess with your rocket's trajectory, because these are not actively guided rockets. These have passive guidance from the standpoint that they have fins. So by and large, we are at the mercy of wind many times. And so changing things like the launch angle, for example, of your rocket, provided it's within a safe margin, is something that you can do to alter your flight's behavior. But for right now, I'm going to go ahead and just set this back to a value of 0. Oops, cancel that. And at this point here, I'm set. I've been extremely long-winded, but effectively all we needed to do was load in the rocket model, load in the motor, and then we can hit launch. I'm going to hit flight profile instead of launch because it's going to bring up a screen that's going to show us a video interpretation of what the rocket's flight looks like. So if I click flight profile, it brings up this 2D flight profile, and the simulation's already ran. So, you know, it took a second there to run the entire simulation, but now what we can do is we can watch that simulation. So if I go ahead and click the play animation down here, the play button down here, you can see our rocket launching. The flight time in seconds, as well as the altitude. If I hit this details pane on the side, it'll give us a lot of information about accelerations and velocities and the drag coefficient, all sorts of useful information. And I can actually slow down this simulation as well by going from animation step time down here and then setting it to, let's say, 0.01 times the true speed. And let me back that up a little bit so that I hit play again. And you can see that it is going very slow right now. And this gives you an opportunity to take a little bit of a closer look at some of the data values that are showing up on this side screen right here. Set the time back to real time. And you can see that our parachute, just like we told it to, deployed at apogee. And so if we were to sit here and wait for this thing to land, it's going to take a very long time because now that that parachute's out, you know, the descent has slowed to such a rate where it's going to drift for a very long period of time. And if I take this slider down here for the time and then drag that out, you can see that it looks like it's going to be landing approximately, assuming that that is feet, about 3,000 feet away. So, you know, a little bit over, you know, half a mile away from the launch site. And this is on a nice day where there isn't a significant amount of wind. Wind being one of the parameters that you can change when setting up your simulation. So if I go ahead and close this down, you can see that something new has showed up on this feature tab called Flight Simulations. And this is what we just ran. The useful information here is that you can see underneath the results section right here, there is a parachute icon. If you see a parachute icon, that's typically a good thing because that means that a parachute has deployed and the rocket has more or less successfully landed. If you see an icon there that looks like a sideways rocket with a big X through it, it means that something probably went wrong. And you might need to rerun that simulation or rethink the design of your rocket because your rocket probably did not land in a safe manner. In addition to the yes, no on safe landing of your rocket, it gives you information about the motor that was used, as well as, you know, a bunch of general information about the performance characteristics of that flight. But we're going to want more information than that. So what I can do here is, because this is highlighted right now, I can go up to this plot graph button and click that. And then here I can set up a graph of a billion different things, not that much, a lot of different things to graph the function of that rocket over time. We're not going to change anything in here though, because what RockSim has already done for us is populated the most useful and most commonly used data points for graph plotting, which is time versus the velocity in a vertical direction, as well as the altitude off the ground. And so just by hitting plot graph down at the bottom here, you can see what this rocket's flight profile was. And this is a textbook flight profile for a beginner's rocket. You can see that right at apogee, the parachute came out, and then immediately after the parachute coming out, we have this very, very slow, steady, gradual descent down to the ground. And what I can do here is, you can see my cursor is turned into this little plus sign. I can go ahead and drag select over an area like so to get a much more up close view, a much more up close view of what's going on here. Here along the x-axis, or the bottom axis, you can see time. And then the various colored curves here are our velocity, which is given in miles per hour. So it looks like we hit a velocity of somewhere in the range of 450 miles an hour with this particular rocket. And that was just with me picking a motor out of the blue. I was not anticipating a particular speed. And then also on the blue line here is the altitude in feet. So it looks like we were cresting right above 6,000 feet. So this was a pretty high flying rocket, in particular for a beginner flight. But we did good. Other notable items here is that it has given a vertical line here for when the motor burnout is. So this is the point in time where there's no propellant left in the motor. And from this point on, the motor is just, or the rocket is just coasting up to an altitude and then tipping over and then coming back down to the ground. And that's it. We have effectively accomplished our first goal, which is to go ahead and run the simulation with a rocket. And if you're following along at home, if you have any questions, feel free to go ahead and unmute yourself and talk in the chat. Otherwise, I'll just take a minute here to sip this LaCroix and then we'll keep going. Okay, let's take a look at the presentation and see how far we got.
So I have a question.
Yeah, go ahead.
How often should we run a simulation for our rocket? Just like 2 or 3 run-throughs so we know what's going on, or?
Sure. The number of simulations that you run for the rocket really depends on whether or not the simulations that you got the first time around were things that you liked. Now, that being said, you need to make sure that your model is correct too. So if I pull this open right here, or if I move this over to this side again, you know, we ran this one simulation and it landed safely and everything seemed great. But again, if I open up the results from that simulation, you can see here that the rocket is going to be landing very, very far downwind from where we started. And if it's a clear day and it's a bunch of flat ground and you and your team don't mind walking, then that's probably not a problem. But if you are very uncertain about what the weather conditions are going to be for the day of the launch, or you don't have a good feel of what the launch site is going to look like, then you may want to modify your rocket, or perhaps select a different motor, or perhaps change the size of your parachute to make sure that that rocket comes down quicker than what it previously was with this simulation. And that is where the iterative process of running simulations really comes in, because then I think to myself, oh, okay, well, what if, for example, I'll close this down and I'll go back over to our rocket design components. What if I took this parachute and I made it smaller, you know, and that's a really good segue into how to modify the various components that you see in this feature tree. And I can start by just double clicking on this parachute right here and double clicking on that. And a screen comes up here. And don't be intimidated by this, because as you probably discovered, every time that you click a button in RockSim, it gives you 15,000 different things that you can modify. And it's important to remember that in order to at least run your first simulation, you can get a general understanding of what's going on with your rocket. It's, oops, what happened to my screen right here?
So while we're waiting for Trent to be able to get that back up, does anybody have any questions? So a reminder that for each one of you, purchasing the student version. The student license, I believe, is $20, and that can be incorporated into your budget so that every team member that you want to have that available has it. I believe for the Mars and the Moon challenges, you will need to submit a RockSim file with each one of the design review reports.
Okay, I'm back. Hopefully this time to stay. So finishing that thought from the question was, you can go into the individual components and then modify them. And you have a ton of different liberties to go ahead and modify those components. So for example here, I can change the diameter of that parachute from what it's currently set at as 36 inches down to, let's say 25 inches. Actually, let's be really generous here, and let's see. Chris, do you want control of the screen?
I don't need control of the screen.
Okay.
It was when you blacked out.
Gotcha. Let's be really generous here, and let's make it a 12-inch diameter. And again, the way I did that was just by going into this components tree here, this feature tree, and grabbing the parachute, double-clicking it, and then all of these different parameters for dimensions come up, and I changed it from 36 to 12 inches. So if I click OK, and then go to, again, the same way that we did before, go to prepare for launch, and we're not going to change anything in here. We're just going to launch the rocket again, and then compare the results. So if I go ahead and I graph this, you can see that the parachute came down at a significantly faster slope than previously, which indicates that the rocket came down quicker, and thus the rocket did not travel nearly as far. So that's a good question with regards to what causes us to iterate with the simulations in the first place.
When we put our rocket into the RockSim, we can modify all of these different components that our rocket has, so we can get to the parameters of the competition.
That's right. Yes. So another example would be perhaps, maybe you are trying to get to a particular altitude, but just no matter what you do, you stuff the biggest motor that you could possibly into this thing, or maybe you're limited in which motors you can select from, because for my competitions that I was in, we usually had a very select number of motors that we could choose from. And so weight savings was a huge thing. And we often had to, in situations, figure out how to make our rockets lighter so that they could reach a particular altitude. And so for something like that, again, going back over here to the rocket design components, there are two ways you could attack this problem. The first of which is to dimensionally change some of the components associated to your rocket. So for example, if I was dealing with a kit like the Precision ISP, one of the easiest ways to change the weight of the rocket is by adding or removing sections of body tube, or modifying the bulkheads, or the metal rings that are, or excuse me, the wooden rings that are inside of your rocket. So let's take a look at this main section down here, which in the terminology of our current component layout is called the main airframe tube. So if I double click on that, more parameters come up. It tells us the outer diameter is 3.1 inches. We're not going to change that. There's no real easy way to change the diameter of a tube aside from replacing it, and replacing it costs money if you've already bought the kit. But you can change the length, and this is a very useful exercise because it shows a couple of different things you can easily do inside of RockSim. The first thing you could do is you could go ahead and just manually type in a new value here. Right now it's currently 34 inches. I could type in 32 inches. But you can also use this slider right here. And watch as I move this slider here, both in this small representation of the rocket as well as the big one down here below, is that the size of this airframe is changing. And you'll notice that the fins are not moving with it. We can change that too at a later point in time. But right now I'm just demonstrating that I can go ahead and make this very short or very tall, depending on how big that I want to go. And you'll also notice that the motor and the motor tube are currently moving with it. And then we think to ourselves, well, why is that? You know, why are those components specifically moving with that? Well, it's because, remember, feature tree, all of those components that were moving with the main airframe tube are currently branched off of the main airframe tube. You can see the little indentation here. It's just like a folder structure. Now, the reason why those fins aren't moving with it probably has something to do with the fins currently exist outside of that tube and they don't exist inside of that tube. There may be a way to rework this model so that the fins do move with the body tube, but currently it's in a position where you would have to move those manually. Another thing that you're probably going to need for your competition is I highly doubt that any of you are going to be running dumb rockets. And when I say dumb rockets, I mean a rocket that doesn't have some type of electronic instrumentation in it. Now, currently, if we look through our components here, there is currently nothing in here that says altimeter, Arduino, any type of electronic component. And it's not only the electronic components that add weight, but it's also batteries too. And batteries can get significant, very heavy if you're not too careful. You know, even something as small as a 9-volt battery can really affect the flight of your rocket, especially if you have multiple of them. So let's talk about that for a second, because this will be a great example of us adding something to the rocket that currently doesn't exist and that you would need to have in there. So when I look at where electronics would exist in this rocket, there are a couple places that they probably could. The first place you could put them would be in the nose cone. A second place you could put them is somewhere down in the lower chamber here, maybe attached to your parachute, or maybe connected in some way to an eyebolt down by the motor. But the most common place to put your electronics, and arguably the safest place, will be in this coupler tube right here that connects the upper half of the rocket to the lower half of the rocket. And if I go over to this section over here in the corner that says add new components, I have a whole bunch of different options. But you'll notice that there is no specific option that says electronics or Arduino. And for the purpose of adding those very specific components, there's one button called mass object. And you can see actually that we already have a couple of different mass objects that are in this assembly. You can see them because of this little M with the parentheses around it. But if I want to go ahead and add a mass object, and in this particular case, the mass object is going to be, let's call it the battery and electronics, just as like one big bulk item. I'm going to go ahead and select which component on my feature tree I want that mass object to be branched underneath. And then going over here to the corner, I am going to click mass object. Now, RockSim wants to be very helpful. And so what it's going to do is, before it allows you to input information about how much that mass object weighs, is that it's going to bring up another database, similar to the database that we saw for rocket engines. But in this particular case, it's trying to think of all the things that RockSim would qualify as a mass object. And so it looks like we have motor retainers in here, we have metal quick links, we have screws, eyebolts. None of these things are really interesting to me right now, but they will be at some point to you, perhaps, when you're trying to find and add components to your rocket. Right now, I'm just going to click cancel. And it's going to bring up this more generic screen here. And the name of it currently says mass. And so I'm going to get rid of the name mass. I'm going to call this electronics plus battery. And if you were doing this in real life, maybe you have the electronics in front of you and maybe you have access to a small scale and you can just set them down on that scale and then find out that the mass of the electronics and battery together weighs something like, I don't know, let's say 50 grams. Or alternatively, if you don't like working in grams, this is really great. And I love this about RockSim. This is that for each individual parameter, it allows you to quickly change between units. And units, love them or hate them, they almost never stay consistent. And that is true in both the amateur rocketry world and is absolutely 100% painstakingly, annoyingly true in the my day job, working on rocket engines for NASA and other, other folks, that you always end up with a weird combination of units between grams and kilograms and pounds and feet and gallons and liters. And unit conversions are something you get used to a lot, but we don't have to do unit conversions right here because it allows me to choose my preferred units. And I'm going to stick with grams for now. And then it's going to give me the option of location. So by default, it's going to start the location at 0 inches. And that's 0 inches starting from the top of that parent component, which is this payload section airframe 2. So if I take this slider, or alternatively, I can go ahead and put in a number manually here, but I'm just going to take this slider and we're going to drag that. You can see it moving down here at the bottom, that little M. I'm going to go down, 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 down until it gets right to the center of this coupler tube, because that is where I want that component to exist. And I'll click OK. And then what I would do, and this ties back into the iterative process, I can go back up and I can prepare for a new launch with this slightly modified version of my rocket. Click launch. And now I have a third simulation down here, which I can go ahead and plot the values from. Now, I did not add that much weight, and I guarantee that there's a difference in the altitude and the flight and the velocity, but you would have to zoom in pretty close to see it. And for your reference as well, if you want to see these all side by side with each other, I'm sure that there's a way to do that within RockSim, but you can also print these too. And if you click that print button there, then it'll print either a picture or a PDF format of this graph that you can then save, and then you can use it in your documentation or your reports or your PowerPoint presentations, whatever is necessary to document and demonstrate. Those are the 2Ds, the document and demonstrate the flight characteristics of your rocket. So let's take a look back here at the presentation. Okay, choosing engines, flight simulation, display details, flying the rocket and seeing the 2D flight profile in real time. Yeah, I think that we have covered most of the basics. There is one more thing that I would like to do with you all, but I don't think that we're going to have enough time to complete it in the next 4 minutes. Christine, if we can run over, that would be something I'd be okay with, but otherwise, effectively, it was just another example of modifying something on the stock kit of the rocket.
So what I think we should probably do is just go through, some of those simulation tips to run through those. And then if there is anybody that wanted to stay on afterwards, they could, and you could go over with them, but then giving everybody else the option to finish up. So sure. I can even take over for the simulation, or Mark, if you want to jump on, or Frank. Just a reminder that you want to be updating that simulation often. and especially as you're getting the different parts in. And then remembering, as I believe I put in the chat, that you will need to submit your RockSim file with each design review phase. And so once you hit CDR, your build should be complete and you shouldn't be making changes after that. So that's kind of that final kit. And then you'll also have your final motor selection prior to that. And so as Trent was going through and showing you the different rockets and how to put that in, that should all be pretty static. You shouldn't be making any changes at that point. So you should, your RockSim should be pretty good, unless I'm misspeaking in any way.
Nope.
Okay. I'll let you go back to the screen, PowerPoint, Trent.
Oops.
And then the next screen, please. So resources, I believe we tried to put almost all of these in the chat, except maybe thrust curve I didn't get in there, or the tutorials. I will try to pull this up on my home screen as well, so that I can drop it in the chat for you guys so that you have it and can quickly copy it yourself. And then also for all of you, your mentors should be a great resource for you if you need them. Again, we're great resources as well. Mark, Frank, Genevieve, and then the last page. I'm going to click it, Trent, like trying to help you there.
Yeah, sorry.
And we'll go ahead and drop those in the chat for you to copy as you need for yourselves. And with that, to the last screen, and any questions for myself, for Trent, or for anyone else. If not, I do want to thank everybody for your time and for joining us. And if you want to stay for that further tutorial, simply put your name in the chat so Trent knows and he'll stay on with you. All righty.
Thank you, Christine.
You are welcome. And Connie, when is our next webinar? Oh, you're on mute.
Let me see.
Or Sarah, either one of you guys.
The 16th of November, proposal budget design review.
All right, so that will be next week, and that will be with Genevieve Benali, and she will be going over what the expectations are for the design review process and for your proposals that are due.
Thanks, everyone.
You're welcome. Thanks, Becky.
Yep. Have a good one.
Thank you. And stop recording.